Alright, in this video we're going to talk about the transformations and how those can change our domain and range of our various parent functions. So we'll start with the square root of x parent function. I've already graphed it here. I used 3 critical points, and just so you know, when I say critical points, I'm talking about when I go into my calculator and I put in square root of x. I go in my table and I want to find where my y values are whole numbers. So I've got 0, 0, and then I've got 4, 2. You see that? How y is a whole number, because that makes it easy for me to put a point on the graph. And then I used 9 down here, 9 and 3 right here. So that just makes it easy to graph. Just so you know, when I say critical points, that's what I mean. It helps you graph it easily. Okay, so let's start with the first transformation. Oh, notice also we've got our domain and range picture here. Domain is our x's, range is our y's. Remember this picture. It will help you keep those straight. I've gone ahead and put in my domain and range of my parent function. In set builder notation, it's the domain is all x's such that x is greater than or equal to 0. Because anytime I want to get my domain, I find my minimum x, and then I find my minimum y. And in this case, I'm going to do this back in blue so that we keep this straight. So I'm going to find my minimum x, my min x, minimum x, in this case is equal to 0. So that's my minimum x right here. Then I find my maximum x, and in this case that's infinity, because it goes on forever in the positive x direction. So that makes it easy for me to then determine my domain. So when I have this case, my minimum is 0, I want to say all numbers 0 and bigger, and that right there is the proper way to do that. This right here. This says all x's that are 0 and bigger. Okay? Now, same thing when I find my y's, when I find my range, I'm going to find my minimum y, start there, the same process every single time. Minimum y, my minimum y in this case is 0, so my minimum y was 0, my maximum y. This graph continues to drift higher as x approaches infinity. So as it continues to move this way, it's drifting higher and higher and higher. So it will also be maximum y will be just infinity, because it keeps going on forever. So in this case, notice my minimum x is 0, minimum y is 0, maximum x is infinity, maximum y is infinity. So my setup is the same, only I replace my x with y. X greater than or equal to 0, y greater than or equal to 0. Okay, so let's look at one transformation. So let's say that I was asked to move this graph up 3 units. And we recall from our shift chart that to move up 3 we need to have a plus 3, because we go in the direction. For a vertical shift, we go in the direction of the sign. And if you're still confused on that, watch our video, first video in this series on transformations, and I think it's called vertical and horizontal shifts. So when that happens, we have the plus 3 will be outside of the radical sign or whatever's going on with x. In this case, it's the radical sign. So our new equation for that, if we had to write the equation, would be square root of x plus 3. So we could check that in our table, and we'll do that on this one. So we've got our square root of x there. Now we're going to put our square root of x, close parentheses, plus 3. Go in our table, find some critical values, and we will see that they are just going to be these values shifted up. So when x is 0, we did have 0. We had 0, 0. Now we have 0, 3. So our y coordinates are shifted up 3. So right here. And then we had 4, 2 before. Before we had 4, 2. Now we add 3 to that because we're shifting up 3. We add 3 to our y coordinate of 2, and we get 5. So now we have 4, 5. So that's right here. And so now we can see the pattern. We did have 9, 3, so we're going to have 9, 4, 5, 6, 9, 6. Just this shifted up 3. So here is our new graph, approximately like that. So now we need to write the domain and range. Okay, we can tell that our domain is going to be exactly the same. We did not change any of our x coordinates. Notice we just shifted this thing up 3 units, just like that. So now all we can say our domain is the same. I'm going to write same as this right here. Our new range, we'll write up here, our new range of our red graph is now going to be all y's such that y is greater than or equal to, symbols don't change, same as this, only we're moving this value up 3. Simple as that. So now it's y, all y values greater than or equal to 3. Close our bracket. Okay, simple enough. Now let's apply one more shift. Let's say that we were asked to move this graph, our square root of x, let's say we were asked to move it left by 3. So left by 3. Alright, so our new graph becomes, if you recall from our transformations video, our vertical and horizontal translation video, we will need to put a horizontal shift in with x. So this will now become square root of x minus 3, and everything is under the radical sign. So that will give us a, well, I'm wrong about that. Hold on. See, I messed that up. Even I have to think about this from time to time. So remember, when we have a horizontal shift, we're going opposite of the sign. So if I want to go left 3, I have to put a square root of x plus 3. Let's check that in our calculator, make sure it's right. So we can come in here, we'll put our square root, and we should have graphed the other one anyway, square root of x plus 3, which will give us a shift left. So we're going to graph this. It'll graph our parent function first, then our vertically shifted function, then our horizontally shifted function. So let's graph it. There's our parent, vertical shift, horizontal shift. Okay, perfect. So that moved it left 3 just like we wanted. Let's grab some critical points on this y3 graph. We have the point 1, 2. So 1, 2 right here. We have the point, let's find another critical value. Here's 6 and 3. 6 and 3. Right here. 6 and 3. And then our new value will still be down here at 0 because we only shifted a y value of 0, but we're just going to be 3 left of this. So 1, 2, and 3. Okay, simple as that. Let's check that in our calculator. We'll go second table set, and we'll start our x's at -3. We'll check y3, and y3 is now 0. So -3, 0, just like we said. Alright, so let's get rid of that. Graph this function. Looks something like that. Alright, so let's set up our new situation here. We notice that our range, we did not change our y coordinates in any way. We did not shift this vertically. So our range is going to be the same. So for our green function, I'm going to put the same. So that's easy enough on our range. Now our domain will change. Our domain will change. So we always go through this process. Our minimum x now, our minimum x is now equal to -3. -3. Our max x, maximum x is still equal to infinity, just like it was before, because this graph goes on forever. So I can just put in my infinity sign, and that makes it easy to set it up. So our range stayed the same. We did not shift this thing up or down in any way. So all I need to write is my statement for domain. So my domain is now, domain is all x's such that x is, symbols stay the same, all x is greater than or equal to, and now instead of 0, I moved it left 3. So 0 minus 3 is negative 3. So my new minimum x is negative 3. Okay, done. All right, let's look at this example. Let's look at our exponential graph. Okay, so this one, we've got our domain already set up. Our domain is all real numbers. We can see that here, the big R, all real numbers. And our range is all y's greater than 0. We approach y equals 0, but we never get to it on our exponential growth. So we have a y that is greater than or equal to 0. So if we shift this thing right or left, realize, so let's say that we moved it left 1, 2, 3 units. Let's just say that we did that. So this graph would then become 2 to the x minus 3. Remember, when we do a horizontal shift, it's with x and it's opposite of sign. So that would be 2 to the x minus 3. If we did that, all of these points, 1, 2, 3, are going to shift left 3, 1, 2, 3. So we'll be down here, and then we'll start to take off exponentially. And notice our domain and range doesn't change at all here, because we're still going on forever in the negative x direction, and we're going on forever in the positive x direction as this thing continues to drift to the right. Okay, so our domain would be the same. Our domain is the same. And notice we didn't shift it vertically at all, so our range would be the same. Still greater than 0. Okay. Now let's say that we were asked to perform a vertical shift on this. So that would be 2 to the x, and remember, when we have a vertical shift, it's away from x, it's not in with x. So let's say we did 2 to the x plus 5. Let's just say we had that, 2 to the x plus 5. So we are going to shift all of these points up 5. That's it. So now we're going to do 1, 2, 3, 4, 5. Put a point there. Take this critical point, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's going to be off our graph here. And we were approaching a y of 0 before, so now we're going to approach 5 more than that. So 0 plus 5 is 5. So we're going to be approaching y of 5, but never quite touching it. And then we'll take off like this. So there is our vertical shift up 2 to the x plus 5. So now our domain, notice it will not change. Our domain is still the same. So I'm going to write same here. We did not shift this thing. It goes on forever in the positive x direction and in the negative x direction. However, we did make a vertical shift. So we, in this case, will need to update our range. So we will write that this way. Our new range is all y's such that y is, we'll keep our same symbols, y is now greater than, we add 5 to that number right there. We add 5 to that 0. So now it's y is greater than 5. And if I went through the same process, I could say my minimum y is now greater than 5, just above 5. It doesn't ever get to 5. And my maximum y is still infinity. Okay? So that's that setup. Let's look at one more setup, and you'll have this down, I'm sure. So now we'll look at the rational parent function. I've gone ahead and graphed that in. A couple of components on the rational parent function. We know we've got a vertical asymptote at x equals 0 right here. An asymptote is a line that we approach but never cross. All right, we have a horizontal asymptote at y equals 0 right through here. So that's the behavior of the rational parent function. I've gone ahead and put in the domain and range for this parent function, so let's look at that and why it's that way. We are saying here that our domain is all real numbers. Our x's are all real numbers except x cannot equal 0. Notice it can't equal 0 because we've got an asymptote there. We never touch it. So that's the proper notation for that setup. Then same thing applies with our range. It's all real numbers. It goes on forever in the positive y direction, goes on forever in the negative y direction, but we have this break in here. It's not continuous right here at y, and I need to put that in there. Y cannot equal 0. So it's all real numbers for y, everything up here, everything down here, except right here at y equals 0. That is not included in our range. Okay? So let's look at a couple of transformations. Let's say we were asked to move this 3 units left. So let's say we were asked to go 3 units left. Okay, so when we do our horizontal shift, recall that we will need to put our number, our 3, with our x, and we need to go opposite of the sign. So in this case, we would have to rewrite this equation. It would be 1 over x, opposite sign would be plus 3, just like that. Okay, so let's grab some critical points. Let's go clear all these out. Whoops, skip that one. So we'll do our parent function 1 over x, so that we've got that in there. And then let's do 1 divided by, to put it in the calculator properly, we need to do 1 over x plus 3, close parentheses. Whoops, I missed my x there. X plus 3. Alright, got it. So now we're going to graph this. So we are predicting that this will move left 3. So it should take this whole thing and just move it left 3. So let's see what happens. We're going to graph our parent function first. There's our parent function. And now there's our new function. And we are in fact moved left 3. So the best way to graph this thing now is, first of all, to move our asymptote lines. So now our new asymptotes become, instead of at x equals 0, it's now going to be x equals negative 3, because we are shifting that asymptote over 3 units. I'm going to draw this dashed line in here. And I did not shift it vertically in any way, so I still have an asymptote at y equals 0. So now I can just put my graph in here. I know I'm going to have a critical point right here. Negative 2, 1. Let's just double check that. For our y2, we should have negative 2, 1. We do, because notice our critical point is moved 1, 2, 3 left. Down here, it will be moved 1, 2, 3 left. So we should have the point negative 4, negative 1. So let's look in our calculator for that. Negative 4, negative 1. There it is. Now we just fit our curve in here. Just like this. And just like this. Okay, so there's our shift there. Okay, so let's talk domain and range now. So our range, because we did not make a vertical shift of any kind, our range is the same. Our range will still be all real numbers except y cannot equal 0. So we're going to put the same there. So now I need to look at my minimum x value in because my domain is different, and I still see that in this case I was approaching 0. Now I'm approaching negative 3. So all I have to do is change this, change to negative 3. That's all I have to do. Change that to negative 3. So I can rewrite my domain statement as domain is all x's. That includes real numbers, except that x cannot equal negative 3. Okay, there's my new statement, because I shifted this to the left 3. Okay, let's do one more quickly, and we'll shift this thing vertically. So let's say we were asked to shift this vertically. So that's going to be, let's say we were asked to move that up 4 units, up 4. We know that that now needs to be away from the x, and it needs to be with the same sign. So we need to go, the new equation will become 1 over x, I'm going to put that in parentheses to keep it straight, plus 4. Okay, So let's put that in our calculator. Alright, so we'll parentheses 1 over x, 1 divided by x, plus 4, graph it, and you can see that's the one it just graphed in there. So it's the same as our blue graph, only shifted up 4 units on the in our quadrant 1. So let's do that in green. 1, 2, 3, 4, right here, and we'll go down 4 units down here. 1, 2. Oh, I'm sorry, we're still going up 4. See, I still make mistakes. 1, 2, 3, 4. So there's our critical point. We need to move our asymptotes up 4 units as well. If you look at this graph, notice we're up here and up here. It's kind of getting crazy on this graph, but you'll see in a minute. We're just moving our asymptotes up 4. We still have our x equals 0 asymptote right here, so we will that'll be the same. Now our y equals 0 asymptote needs to shift up by 4 units, so we will have an asymptote right here at y equals 4. And now we can draw our graph in. We'll approach our asymptote up here. Let me do this in green. Approach our asymptote up here and go through our critical point there. And then we have our asymptote here. I know this graph is getting busy, I know, but I want you to see how our domain and range will change. Okay, so we only made a vertical shift. So does our domain change at all? No, it does not. Our domain does not change at all. So we can write the same here. We can write the same here because we did not shift it horizontally in any way. We only shifted it vertically. So now we need to change our range statement. And all we have to do is change that number right there, and we change it by adding 4 to it. So our new range for our green graph becomes, range is, let me redo that. Our range is now inclusive of the real numbers, except that y cannot equal positive 4. Done. Okay, so we've gone through several different parent functions and all different types of shifts. So that was a bit of a review, and then we talked about the domain and range of each. So hope that helps. So there's that picture again. Here's our exponential examples, and then here is our rational function examples. So I hope you're getting the picture that the shifts can be applied to any of the parent functions, but the domain and range, the patterns will be the same, but the structure of the domain and range will depend on what parent function you started with.